Greetings students. Let us see how to solve the given nonlinear function with equality constraints by the method of Lagrangian multipliers. Okay. Let us see this method with one example. Solve z is equal to x1 square plus x2 square plus x3 square subject to the constraints x1 plus x2 plus 3x3 is equal to 2, 5x1 plus 2x2 plus x3 is equal to 5, where x1, x2, x3 greater than or equal to 0. Okay, so first you have to frame the Lagrangian function capital L. What is Lagrangian function? Capital L, which is defined as f minus summation lambda I hi. What are these notations f, hi, lambda I? All those we'll get from the given question. You'll be asked to solve a nonlinear equation. No, that nonlinear equation we name it as the function f. So here in this problem, f is x1 square plus x2 square plus x3 square. h1, h2, etc. hi is nothing but subject to constraints. Here how many constraints are given? 2 constraints. So we name it as hi. That is h1, h2. h1 is the first constraint function. Okay. So x1 plus x2 plus 3x3 minus 2. h2 is the second given constraint 5x1 plus 2x2 plus x3 minus 5. So lambda I is nothing but Lagrangian multiplier which depends on the number of constraints. If there are 2 constraints h1, h2, then you have to introduce 2 multipliers lambda 1, lambda 2. So for this given function, the Lagrangian function L becomes x1 square plus x2 square plus x3 square minus summation lambda I xi. That is lambda 1 h1 plus lambda 2 h2 with both sign minus. Okay, lambda 1 h1. So lambda 1 h1 is x1 plus x2 minus 3x3 minus 2 minus lambda 2 h2. That is 5x1 plus 2x2 plus x3 minus 5. So this is our Lagrangian function. Next, first step, we are going to solve this by 2 steps. One is, having this Lagrangian function, we are going to get the partial derivatives of this L with respect to the unknowns x1, x2, x3, lambda 1, lambda 2. Solving those 5 equations, we'll try to get x1, x2, x3 unknowns. Okay, that is first step. Next step, those unknowns x1, x2, x3, we name it as extreme points. Next step is checking whether that extreme point is maximum or minimum. Okay, so the problem is just solve. So it is maximization problem or minimization problem is not precisely given. So we have to find it in step 2. So first step is finding extreme point. Second step is finding whether the problem is maximization type or minimization type. So let us do it one by one. First step, to find the extreme points x1, x2, etc. from this Lagrangian function L, find dou L by dou x1, dou L by dou x2, dou L by dou x3, equate it to 0. Similarly, Lagrangian with respect to Lagrangian multiplier also. Dou L by dou lambda 1 equate to 0. Find dou L by dou lambda 2 equated to 0. So totally you will be getting 5 equations to find 5 unknowns x1, x2, x3, lambda 1, lambda 2. Let us find it one by one. Dou L by dou x1. Differentiating this with respect to x1, it is 2x1 minus lambda 1 minus 5 lambda 2 is equal to 0. With respect to x1 alone, you are differentiating means treat all other variables as constant. x2, x3, everything will be treated as constant. Mark it as equation number 2. Differentiate with respect to x2 means x2 alone is variable. So 2x2 minus lambda 1 minus 2 lambda 2 is equal to 0. Mark it as equation number 3. With respect to x3, if you differentiate, x3 square is 3x3. Here you have x3. So differentiation is minus 3. Here you have minus. So which will become plus minus 3x3 or plus 3x3. Actually, this function is plus 3x3. I'm sorry. So when you differentiate with respect to x3, it will become minus 3 lambda 1. Here you have x3. Differentiation is 1. So here you have minus lambda 2 is equal to 0. Equation number 4. Dou L by dou lambda 1. Differentiation of this is minus of x1 plus x2 plus 3x3 minus 2. Equating it to 0 will give you minus of x1 plus x2 plus 3x3 minus 2 is equal to 0. Simplifying this, you will get same h1. x1 plus x2 plus 3x3 is equal to 2. Mark it as equation number 5. Dou L by dou lambda 2 is equal to 0. Same way, if we simplify, it will become the equation 5x1 plus 2x2 plus x3 is equal to 5. Equation number 6. Now we are going to solve it. So first consider equation 2, 3, 4. From that, I am going to get the values of x1, x2, x3 purely in terms of lambda 1, lambda 2. So from equation 2, how can I write x1? So from equation 2, x1, 2x1 is equal to lambda 1 plus 5 lambda 2. So x1 is lambda 1 plus 5 lambda 2 by 2. Similarly, from equation 3, x2 is nothing but lambda 1 plus 2 lambda 2 by 2. From equation 4, x3 is nothing but 3 lambda 1 plus lambda 2 by 3. Okay, I have got x1, x2, x3 from equation 2, 3 and 4. So I am going to substitute this x1, x2, x3 values in 5 and 6. So I have to use these 5 equations alone to get the unknowns. Okay. So from 2, 3, 4, I have got x1, x2, x3. Now I am going to substitute these in 5. So x1, x2, x3. So mark it as equation number 7, 8 and 9. So use 7, 8, 9 in 5. So 5 becomes x1 plus x2 plus 3x3. So for all x1, x2, x3, I have denominators. I'm going to take it common. 1 second. What is my equation number 4? Let me check it. So 5x1 with respect to x3 means it is 2x2. Sorry. Just make a change here. x3 square, if I differentiate, it is 2x3. So it will become 2x3 here. Okay. So make a change here. So x3 will become 3 lambda 1 plus lambda 2 by 2. Got it? x3 square, if I differentiate, it is 2x3. By mistake, I have written it as 3x3. Okay. So substituting 7, 8, 9, x1, x2, x3 in 5, I'll get lambda 1 plus 5 lambda 2 plus x2 is lambda 1 plus 2 lambda 2 plus 3x3 means 3 times 9 lambda 1 plus 3 lambda 2. For all the denominator is same by 2 is equal to 2. Simplifying this, I'll get lambda 1 is 11. 11 lambda 1 plus lambda 2 is 5 plus 2 plus 3. So 10 lambda 2 by 2 is equal to 2. When I bring this denominator 2 to the other side, it will become 4. So mark it as equation number 10. Similar way, substituting 7, 8, 9 in equation number 6, that is 5x1 plus 2x2 plus x3 is equal to 5. This becomes 5 times x1, that is 5 lambda 1 plus 25 lambda 2 plus 2x2, 2 times x2. So 2 lambda 1 plus 4 lambda 2 plus x3, that is 3 lambda 1 plus lambda 2 whole divided by 2, which is equal to 5. Simplifying this, I'll get 10 lambda 1 plus 30 lambda 2 is equal to 5 2 10. Mark it as equation number 11. Now you see equation number 10 and 11 are nothing but system of equations with two unknowns lambda 1, lambda 2. So I am going to make use of calculator to find the value of lambda 1, lambda 2 first. So using equation 10 and 11, by solving as system of equations with two unknowns lambda 1, lambda 2, the calculator I am going to get the value of lambda 1, lambda 2. So I'll get it as solving 10 and 11 gives me lambda 1 is equal to 0.087. Lambda 2 is equal to 0.304. When you solve the system of equation using calculator, the general format is A1 lambda 1 plus A2 lambda 2 is equal to A1 lambda 1 plus B1 lambda 2 is equal to C1. A2 lambda 1 plus B2 lambda 2 is equal to C2. That is the general format. It will ask for A1, B1, C1, A2, B2, C2. If you enter it, you will get this value lambda 1, lambda 2 like this. Now substitute this lambda 1, lambda 2 values in 7, 8, 9 because our aim is to get the extreme points x1, x2, x3 from step 1. Okay, ma? So substitute lambda 1, lambda 2 values in 7 first. So x1 becomes 0.087 plus 5 times 0.304 divided by 2. That is, simplifying, it is 0.804. Similarly, substituting lambda 1, lambda 2 value in x2, we'll get 0.348 and in 9, if you substitute 3 lambda 1 plus lambda 2 by 2, we'll get x3 as 0.283. So the extreme point is, we got it as x1 is 0.804, x2 is 0.348 and x3 is 0.283. Now we have to check whether this extreme point is maximum or minimum. That is, the given question is of maximization type or minimization type. For that, we are moving to step 2. Step 2 is checking whether the point we have got is maximum or minimum. That we can do by considering bounded or bordered Hessian matrix. We can name it as bounded or bordered. What is the bounded Hessian matrix? Bounded Hessian matrix is denoted as HB and which is nothing but O matrix P, 0 matrix P, P transpose Q. Okay, here O is nothing but 0 matrix, square matrix whose order depends on the number of constraints given. Here the number of constraints are 2. I name it as M. Number of constraints. Number of constraints given here are 2. So M is equal to 2 here. So that gives the order of 0 matrix. So 0 matrix is a square matrix with order 2 here. So 2 by 2 0 matrix. Then what is P? P is nothing but if you have two constraints H1, H2, then first row for H1, second row for H2. So dou H1 by with respect to unknowns. What are the unknowns? X1, dou H1 by X2, dou X2, dou H1 by dou X3. Second row for H2, dou H2 by dou X1, dou H2 by dou X2, dou H2 by dou X3. Okay, we'll find this. What is H1, H2, H3? H1, we have H1, H2, only 2, right? H1 is X1 plus X2 plus 3X3 minus 2. H2 is 5X1 plus 2X2 plus X3 minus 5. Okay, let us find P. First, O is 2 by 2, 0 matrix. P is nothing but dou H1 by dou X1. With respect to X1, if you differentiate 1. With respect to X2, 1. With respect to X3, 3. H2 with respect to X1, 5. With respect to X2, 2. With respect to X3, 1. Transpose of this is row into column. Second row into second column. Okay. Last one is Q. What is Q matrix? The Q matrix order depends on the number of unknowns. How many unknowns we have? X1, X2, X3. So order of Q is 3 by 3 matrix, whose entries are nothing but second derivative. Dou square L by dou X1 square, dou square L by dou X1 dou X2, dou square L by dou X1 dou X3, dou square L by dou X2 dou X1, dou square L by dou X2 square, dou square L by dou X2 dou X3, dou square L by dou X3 dou X1, 3 1, 3 2, 3 3. Okay. Dou square L by dou X3 dou X2, dou square L by dou X3 square. Okay, so already we have found dou L by dou X1, dou L by dou X2, dou L by dou X3. We are going to find the second derivative. What is dou L by dou X1? We have found 2x1 minus lambda 1 minus 5 lambda 2 is equal to 0. No? Second derivative with respect to x1 will be 2. So from where I have got this? From already first derivative I have found out. Where? Dou L by dou x1. What is dou L by dou x1? I have got 2x1 minus lambda 1 minus 5 lambda 2. So dou square L by dou x1 square is differentiating with respect to x1, 2. So dou square L by dou x1 dou x2 is differentiating dou L by dou x2 with respect to x1. There is no x1 here, so it will become 0. Like that, we have to find the second derivative from the first derivative which we have already found. Okay, let us find it one by one. So dou square L by dou x1 dou x2. So let me write the values here so that easily I can write. Dou L by dou x1, which we have already got it as this. Dou L by dou x2, already we have got it as 2x2 minus lambda 1 minus 2 lambda 2. Dou L by dou x3, we have got it as 2x3 minus 3 lambda 1 minus lambda 2. Dou L by dou square L by dou x1 square is 2. Dou square L by dou x1 dou x2 is, there is no x1 present here, so it is 0. Dou square L by dou x1 dou x3 is, with respect to x1, if you differentiate, there is no x1 present here, so 0. Dou square L by dou x2 dou x1. So here there is no x2 present here, so 0. Dou square L by dou x2 square, it is 2. Similarly, dou square L by dou x2 dou x3 means dou L by dou x3, if I differentiate with respect to x2, there is no x2 here, so it will become 0. Similar way, you can find the third row also as 0, 0, 2. You can check it out. Okay. So the matrix frame here is called bordered Hessian matrix, or in other words, bounded Hessian matrix. Next step, I have to check the minor sign of the minor of this matrix D. How will you calculate D? Starting from sign plus, minus, plus, minus, plus. So first 0 into the corresponding row column you have to delete, take the remaining determinant. Anyway, it is 0 into, so 0. Second is also 0, so it will become 0. Plus 1 into corresponding row column, if you eliminate, it will become determinant of 0, 0, 2, 1, 1, 5, 0, 0, 1, 2, 2, 0, 3, 1, 0, 2. Okay. Next, minus 1, corresponding row column, if you delete, it is determinant of 0, 0, 5, 1, 1, 5, 2, 0, 1, 2, 0, 0, 3, 1, 0, 2. Last one, plus 3 into determinant of corresponding row column, if you eliminate, this 3 into determinant of 0, 0, 5, 2, 1, 5, 2, 0, 1, 2, 0, 2, and 3, 1, 0, 0. This determinant values we have to calculate, and we have got it as 460. The value we don't want, only the sign we need. How can you conclude the problem is of maximization or minimization type? The problem is said to be of maximization type if the sign of D coincides with -1 the whole power m plus 1. And the problem is said to be of minimization type if sign of d coincides with -1 the whole power m. What is m here? Number of constraints. How many constraints we have? 2. So -1 the whole power 2 plus 1. That is 3, which we got -1, so it's negative. -1 the whole power 2, that is 1, that is positive. So our d coincides with what? D is positive, so that coincides with this. So the problem is of minimization type. So the extreme point we have got, that is 0.804, 0.348 and 0.283 is minimum point. And hence Z minimum is nothing but, in the given question, x1 square plus x2 square plus x3 square, we have to substitute the values 0.804, 0.348, 0.283 in the place of x1, x2, x3. If I substitute it and simplify it, I'll get it as 0.8476. We can check this value. When I substitute x1 as 0.804, x2 as 0.348, x3 as 0.283, I'll get Z value as 0.8476, which is minimum value of Z, because we have got the value as minimum from the bordered Hessian matrix. Okay. Hence, we can conclude the problem. Thank you.